Is that up? Here, I'll hand this to you.
Okay. Good to start? Okay, cool. Great. All right. I'm Jaideep Gajrawala. I am here to talk about local development and kind of some of my experiences that I've had recently. I'm a principal software engineer over at Revology Health out of Iowa City. I work right here in Des Moines. Outside of, and I primarily work on AWS cloud development. A lot of my work is usually large integrations, building a lot of APIs, and now I am dabbling in front end. So, and then outside of work, enjoy cycling, cooking, and a lot of Netflix. So, because that's learn a lot of things on Netflix. So when Min kind of asked me if I wanted to talk here, I started to I was thinking about what would I talk about? And lately, for the past probably 6 to 9 months, a lot of my focus at work has been just improving developer experience as we onboard new developers and building out desensitized data sets. I work with healthcare data, and so we have a lot of patient data that we need to clean up, so we've got test databases that we can work off of. And then Postgres database tuning is something that I kind of landed upon, but have really enjoyed. And so a lot of this kind of goes with just developer experience and things, all of these things kind of turned into things that different tooling and different processes that we built to improve the local development experience for the developers on the team. So I'll kind of cover the problem. Local development can be painful. Some tools and techniques that we've used recently. And then most of the presentation is going to be a live demo. So hope everything goes well there. And then we'll wrap up with some questions. And you can stop me anytime during the presentation. So if you have questions. Some of the challenges with local development, we probably have all faced this. You tend to join a team or a company. You're probably going to be, depending on the size of the company, there's going to be a lot of processes in place, a lot of security. You may or may not be able to download software on your machine easily. There might be documentation out there. But either way, it's usually long onboarding processes. And when you do finally get into the repository or repositories that you're going to be working on, there's usually a README or Confluence of how do you work, what do you do with this thing when you first get in there. And so what tends to kind of happen is you've got outdated documentation. It's really hard to keep up with all the feature changes. You're always adding features or making changes to services and things, and it becomes a little bit difficult. No matter how hard you try to kind of keep up with the docs. And then also, as time goes on, there's a lot of updates that happen. You tend to find that companies will have a process to update your software one way, then it's a little bit different. And as much as you keep those docs updated, it can be difficult to reproduce that same exact environment, machine by machine. And then just complex setups, dependencies. Depending on what you're working with, like installing databases, I do a lot of work with Postgres. I work with SQL and Dynamo. So you tend to have to install a lot of these tools locally. Depending on when you joined, you may be getting updates. You might not be getting updates. Somebody's on 15, someone's on 16. of Postgres version. And so you tend to, a lot of the minor versions, you tend to see a lot of differences in, but sometimes you see differences on Python versions. You want to be using Python 3.11, but oops, you don't have your virtual environment set up and you've been testing and coding in 3.9. And then installing Python, Node, just different toolings that you need to, like AWS CLI, things like that to kind of get you up and running these days. Toolings and like different tools and versions, like I mentioned, IDEs, a lot of extensions in like VS Code and linters. So I think on every team that I've ever worked on, somebody always is using a linter that nobody else is using on the team. And so you tend to find yourself, you see a PR and it's like everything's changed because they've decided, maybe like introduce like black formatter and it's just going to be, you just see all these changes. So, and then because you're constantly making updates, you are breaking local development at times as new features and new technologies are coming into those repositories. And then lastly, data management. This is another thing that I'll kind of touch on is as we've gone to the cloud, in my experience, what I've found is data is you code, you do some unit testing, and then you ship it out to your test environment out in the cloud, and that's where you're doing a lot of your integration testing and making sure things work. But you don't have access to that data easily on-prem on your machine. And so depending on the setup, currently I have one dev has one AWS account or our region, and so you kind of have your own private account. But on other teams that I worked on, we would have like 5 devs or 10 devs in a single account. And so a lot of data is being changed. And so when you go out there and you're testing, you don't have that clean data set and no easy way to reproduce, like if you just want to reset that data back to base. And so you get a lot of it works on my machine at the end of the day, and it becomes a little bit challenging. So this is kind of the problem that we've been trying to solve is how do you onboard a dev and can they start coding and maybe get a PR out there by the end of the week or end of day 2. How do you just speed this process up? But then also, how do you make sure that when we're all doing work that we're all like using the same environments and we're not finding things when QA gets to it or it makes it to production. So my history of working, I'll kind of date myself a little bit here, but when I started, it was really easy, or I thought it was. I would have software installed like Visual Studio. We would have a web app or a batch application or something. You'd hit F5 and it just magically spun up. I didn't know what was going on. It just worked, like everything works. And we would have test databases and you could connect to them right from your local machine. And so you could do all of your development, really easy to do debugging of your code. And that life was easy. After that, we started building APIs, and depending on the team that you worked on, sometimes the APIs in the batch or the web app, they were all in like a single project, in a single repository, which wasn't too bad. If you worked on other teams, they might have separate repositories for your APIs versus the front end. And so you kind of found yourself, you can see on the left, like that F5 button, you kind of found yourself loading up more. You were having to do more work just to like debug your code. And then we got really crazy and we started to build many APIs, experience level APIs to process level APIs and system level APIs. And so we found ourselves like, we have to run like 3 different projects just to like test something, or you were not really testing that well until you just ship your code out to test. And that's where you tell you're testing. And then came AWS. I feel like that has just like introduced a whole new world where things are not readily available in a lot of people's machines. You can code, you can test your code, but when you're just talking about back in the day when you just hit F5 and you could run your code and debug it, this has become a lot more challenging. There's a lot of services out there. There's a lot of different ways to do things. And the meme on the right, just to host like a whole world, it could be really simple or you could make it super complicated. And so it has just become challenging to do development locally for many teams. And until we get more tooling out there or it gets a little bit easier, it seems like we're going to be in this world for a while. So a lot of the work that I do is in AWS. We have a product that uses Vue.js, similar to kind of React. It's its competitor. And then we build we use API Gateway, Lambdas, some event bridge messaging. And so what we were doing is we were doing a lot of shipping of code out you would make some changes, you'd do some unit testing, and then you would commit that code, go to GitHub Actions and press the button and then wait. And we were doing that. So what we decided to do is we wanted to see if we could use some containers and run some of these services locally, maybe run our Postgres locally and make it easy to kind of spin up this environments. So some of the benefits that we were hoping for is quick environment setup. So you're just able to maybe run a few commands and have all of your services up and running on your machine. And just being able to tear that environment down when you're done with it. And the next thing was consistency across like teams and developers. So like I mentioned, you'll kind of get times where you're working on many projects. One repo's in a certain Python version, another one's in a different one. And if your machine isn't really set up and your repos aren't set up to really just have your virtual environments kind of built properly, you're going to find yourself in different versions. So containers are going to make your developers and cross teams kind of use that same exact platform. So they're testing in the same exact environment every single time. And then just improve collaboration. Where this really goes to is usually developers are in the repositories, but now with a lot more teams are adding automated QA. They too are going to be in some of these repositories, but you also have a lot of business folks that are pretty savvy, and you kind of have teams that are getting closer and closer to where code is coming from not only the development team, but like people outside of your team and people that are close to, that are really tech savvy that can do this. So it kind of helps, and it doesn't really matter what role you're in. The goal was to kind of make it easy if you did want to do some work in it or run some code, that you could open up these repositories and run it with a few commands. And then lastly, with containers, it's going to be really easy. It doesn't really matter if you're on a Mac versus a PC or a Linux. You're kind of running in the same environment. All you need is a lot of processing power. So depending on how big the project is. So what I'm going to do today is most of this talk is really about just going through a demo of building an actual application, just a really simple web app. So I just drew up a simple architecture out in AWS. It's just going to be a simple to-do app using Vue.js. We'll have a couple of services. They would be Lambdas that you would have. So your API gateway, you would have a couple of Lambdas that for either like at service level, or you'd have many Lambdas if you're going by like route. And then we'll have Postgres database, and I'll kind of pull this up, and goal is to start bare bones and then slowly build this up to where we're automating the containers and then adding in helpful commands to kind of make life easy for as people are coming into the team to be able to work throughout this repository we've got. And so when we're done with it, we'll see something like this on your local machine where we'll have containers running multiple services, databases. The Vue app is not in a container because I spent all my time trying to get the other containers set up for the demo. So I'm like, I'll leave that one out next time. So, and then, yeah, we'll go to the demo, and I found some cool memes for it, so. Okay, so I'm gonna pull up, let me make Visual Studio, and I'm gonna start right from scratch here. So I've got a repository. This is just a simple web app, and it has my instruction files on it, so I'm probably gonna forget something at some point, and so it's got my instructions. So if I'm coming in here, just gonna clone the repo onto the desktop. The repository, very simple. It's got a front-end folder. This is where the Vue project is held. We've got back-end folder. There's one service right now. It's just the to-do service. And then we've got just one unit test, thanks to ChatGPT for writing that one. And then we've got migration scripts. So if you've got a database attached to this, we've got some scripts that are in order of building out a few tables. And then we've got test data to populate these couple tables with a little bit of data, so we're able to run this project. So what I'll do is I'm gonna, make sure I don't forget the steps here. I'm gonna spin up the back end here. Before I do that, I should probably install, set up my Python virtual environment and install the dependencies, so I've not done that. So we'll do that here. Yeah. Let's see, you want me to zoom in a little more, or? That's better. Okay. This. So we've got our virtual environment set up here, and then I'm gonna go into pip install. We'll install the Python dependencies. What? Yeah. Do I need? Let's see. So I ran through this multiple times earlier, and pip install was working just fine. So let's see here. What we got? What? What could go wrong? I know, right?
Is it pip 3 or just pip?
Let's try that. Yeah, oh, yeah, good call. Okay, let's try it now. Thank you. It's on my list of things to watch out for. So, okay, so at this point we've got the dependencies set up, and then I'm going to go back out to the front end, and I am going to install the node packages here. Okay, and then I'll kind of spin this up. Virtual environment hitting me again here. Okay, this should spin up now. Let's get our Flask service running, and then I'll do this URL here. And we've got our lovely to-do app. As you can see, designing front ends are not my expertise. But we've got a really simple to-do list. We're only doing dishes if we have time. So everything else we have to do. So gonna add a couple things here just to make sure that this is working. You should see this here. And then what I have set up that I didn't talk through was I've got Postgres set up locally on my machine. So I've got Postgres running, and then should be able to connect here and go look at this data. So you should see the test one that we just added, and I should be able to go and we can delete that test one, and then we can rerun this. And remove that. So at this point, we've got this thing kind of working where I've got a local database running. I've got some data in it. We had to install, our virtual environment. We had to install the dependencies, and for most part, things seem to be running fine. At this point, if you're working on probably a much larger project than this, you might have a lot more chances of making mistakes. So we only have a few dependencies, so everything's working fine. So what I'd like to do next is I'm gonna now build, rather than running the services right on my terminal here, we'll build out a container, and then we'll run those containers locally in Podman, and then we'll spin up both of those containers. So I'm gonna build a second service since one would just be too easy. Okay, we'll build out a user service here. We're not going to use this, but we'll spin it up. So I'm going to shortcut this, and then I'm going to replace the routes here. So it has users in the routes instead of the to-do. So at this point, we have two services. I'm using Flask rather than having just a separate Lambda for every single route, kind of going by the domain service of like the to-do and the user, everything that you need to do, all the different, the posts, the gets, all the different actions you need to take for users is going to kind of live out in this Flask application. And then, so we got that. Get rid of this. And then I'm going to bring over a couple of files here, and then we'll kind of walk through those. So we've got a couple image files that we brought in. I've got this image, just Flask container file here. This would be like your Docker image file. I'm using Podman. But we're going to run this with Python 3.11. So it's going to pull down the Python 3.11 image. We can reuse this image to build for as many services as you want. But we have the to-do service, and then we also have the user service. So we want to be able to reuse this multiple times. And then we want to copy all of our code into the image. So what this image is doing is when we pass in the service name of like to-do or user, it's got this path set up. So it's in the back end, and it's going to go grab everything out of these folders, and it's going to copy that into that image. And then the next thing that we do is we are going to install all of the dependencies that we need to run that service when the container starts up. And then I've got a few other environment variables down here. The main one that we'll be focused on is going to be this Flask debug later. And then I've got another container file here. We're using Nginx for this. As you get more than one service, you're going to find yourself with Flask. It's like you're running one service in port 5000, the next one in port 5001, and you're having to manage that locally. So what this is going to do is this Nginx is going to run on port 5003, and then all of your APIs can just make a call to whatever the route is, 5003 port, and you can, and then it will internally route based on the route. So if you have like the /todos, if you have /users, it's going to pass that on to whatever the port the container is exposed out into. So you could use this for databases, a lot of different services. So there's a lot of use for this, but it's just, you need a way to manage all of the ports rather than like managing every single one separately. So that's what I'm using Nginx for here. And then we don't want to start up every single container separately, like writing commands. So I've got just a Docker compose file here. What this is going to do is you're going to be able to run this Docker compose file. It's saying that I need to start up the to-do service, I need to start up the user service, and I need Nginx for the reverse proxy. And this is going to depend on that these other two services actually successfully got built and are running. And then we give it like the Docker file name that we're using, and then you'll notice that we're passing in the service name here, so to do. So you can do a lot of different things with these arguments to make this kind of play nicely with your repository setup. And then we're attaching a volume. We'll kind of see this come in handy soon. A lot of times with containers, when we originally started, when I first started building this, I would deploy this, it would work, and then I'm like, I gotta change code. Like it's not working, there's a bug, or like something's broken. And so you want to be able to make code changes and have that be reflected out in the code that's running in your container. So you're not like rebuilding these over and over. So what we're doing here is we are just mapping the backend to-do service, and in the container, we're mapping it to the /app folder. And you can have multiple of these. So we had Lambda layers, and so we wanted to be able to map the code for the layers, and you could just add another line and map additional folders. And then for the user service, we're kind of doing the same exact thing here. you also kind of notice that we're having to map these ports. So what this is saying is in the container, these Flask services are going to run on port 5000, but if I want to access them from the outside, like from my computer, it's exposed out as 5002. So this is one thing that you do kind of have to manage and make sure that you don't have multiple services that are on the same port. So at this point, I'm going to see if this spins up. I'm going to pull up Podman here, the UI, and we don't have any images, we don't have any containers. So if you were a new dev or you got a new machine, you're going to see something like this. So we'll come out here. I'm going to close out a bunch of these terminals. And we'll do Podman compose up. And so you can see it's building, based on the dependencies, it's going to build out the services that we need. And then lastly, it will build out the Nginx container. Okay, so the nice thing about this is we're in a single terminal window at this point, and we can see logging from everything. When we first started, we had a task file that would spin up many terminals, and as we started converting our services from just your regular one Lambda per route to kind of a monolith Flask that was doing a bunch of things, we slowly found that 1, 2, it was fine, and then we're like, we've got 6 terminal windows open every time we start this thing. So that was one thing that we solved with this, is you're able to see all of your logging just in a single terminal here. And then if we come up to Podman, be able to see this built out the different images per service, and then we've got the containers that are running out here. So we can come out here, and this might be hard to read. If there's a, but we've got some logs that things kind of started up. We can come out here into the terminal. So you'll be able to see your logs out here. You can see it out in the terminal, but you can see out here that here we've got the files that we copied over that are brought in for this application. So if the to-do service uses one version of Flask, if the other one uses a different version, or you work with like pandas, some of those projects can be take time to replace. So maybe if you're upgrading packages, you might find yourself where even within a single repository that you'll want to get something out to production. So you might work on things kind of iteratively. And so you'll see different versions of libraries just within a single repository. And this kind of becomes a little more challenging as you go to large monolithic repos versus just kind of the smaller repos that might just hold a few services. So we could have just I don't have anything pinned, but we could have a specific thing pinned, like a specific version. And then out here, each of the containers are going to be running that specific version of the library, just like it would in production. So I'm going to see if we can see if the front end is still working. and we can close this. Okay, so this is still working. And we can see there's a few things that were there earlier. The application, the web app is running on my machine. The database is still at this point running on the machine, but the services that we're using are no longer, they're running in the containers. So if we come out to VS Code, we come out here, I've got some commentary here of just some print statements for logging that we're like running this endpoint. And then here's like the JSON object that we sent back to the user. And we'll come out to the database. And we'll go to the Mac version of it here. We'll do select. We'll run this. And then we'll come out here, and I'm going to delete this because I don't want to do dishes today. So get rid of that. And then we'll kind of see that reflected on my local database. So at this point, we've got a few nice features. Like I mentioned, you're probably going to come out here and say, I got to make a change. Like something is, you know, I'm testing something's not working, so I'm just going to do this. Right? I'm just going to put a print statement. We'll come out here. I'll refresh this, and we'll come out to VS Code. Oops, let's see. Print, does this work? That is on the get route. Oh, there it is. So it's going to automatically reload the Flask app. So any code changes that you make are reflected right in the container at the same time. And so this kind of gets spun up again. And so you're able to kind of do coding, still have it run in container, so you're not having to do that rebuild process every single time. So this solves for refreshing data and being able to code and not have to, you know, we're trying to save time by not deploying over and over. So this gets us a little bit further. The next thing that we ran into was, I want to be able to debug this thing, and I want to debug the application, but it's running in the container, but I want to debug it right over here and put a breakpoint. So when you've got a lot, you know, you're sitting there, you're putting print statements and logs, and you're just trying to figure out why something isn't working the way that you want it to. And so let's see if we can get the debugger to work. And so we're able to debug this code right here in VS Code. So in this, I'm definitely going to be using the helper file because there's a little bit of a setup process here. So I'll walk us through this. So to be able to debug, it needs to, we need to open up a port. So when Python is debugging, it's going to debug on this port 5672. That's what's going to be exposed out to us as the user on my machine. In the container, it's going to be running on this 5678 port. A lot of this happens like if you're just on your VS Code and you just press the debug button if your VS Code is set up correctly. But because we're in the container, we have to do a little bit of work. We got to update the Flask container file. And so I originally started off with just doing Flask run. Very quickly found that this was a headache. I'm sure there is a way around it, but I could not get it to work where the debug would work with this. So, so we're going to change this, and we're just going to run that app.py. And that will start the Flask app. And then lastly, when we start this application, we need to, app.py. I'm going to paste this in, and then we can kind of, I think this needs to be 5001. Oh, there we go. I think that I'm going to clean this up just a little bit. We only care. So this is where that Flask debug environment variable comes in handy. This is going to say if we want the capability to debug, we add this in. And so it's set to be true right now. And what this is doing is it's using debug py library. That's going to allow us to do this remote debugging. And then I'm going to get rid of this here. Found that to be annoying. And so as long as you have the container running, you have VS Code open, this is going to allow you to use a launch profile and then say, like, I want to now start debugging. So one more thing we have to do is we have to create a launch.json here. And so when we normally come to the debug, we're going to want to attach the two services. So what this is saying is I want to attach this debug process to this 5672 port. And then it's saying, here is the folder, like the local route to the service. And then here's the remote route to where that code lives. This you have to build. If we wanted both of the services, you would just keep building one for every service. There might be a way to like make it a little bit easier to do, but the way that we had it right now, it's like every service just has this entry. And so we're able to debug all of the services at once. So what we'll do here is I'm going to come out here. I'm just going to rebuild all these containers. Okay, we'll do podman compose up, build this. Make sure I didn't leave a step out of there. Okay, let's see if this works. Let's see if this app is still working. It is not working. Is this still? see, I probably forgot a step somewhere. I'm gonna go back to my instructions and see what I forgot to do. Let's see. Got the debugging port set up here. We're listening, but it's not actually able to make that connection. So let me see here if I've let's see, we've got the services set up. 5,000. I'm gonna try. Does not like that. Nope, it doesn't like that. I'm going to bypass this. This was really tricky when I was working on it earlier, and I have a feeling that I didn't write down a single step, and I have a feeling it's this port that I've didn't write this down correctly. So I'm going to bypass this just for the sake of time. I'll put this repo's on GitHub, so I'll update it once it's working. So I am going to move away from this. And I'm going to go back to how the code was before. Okay, back here. And okay, so the app's currently, we're able to hot reload the app, make changes. We've got the services in the container, and then the one thing that we don't have in the container right now is the Postgres database. So what we'll do here is we're going to build a container for the Postgres database. Pull the files down. Really simple image file with some really secure passwords. So we'll just build a simple Postgres database. Password is password. And then we're gonna seed some data and build out the schema, and then add some test data to it. So what this command does is everything that kind of gets put into this Docker entry point, this folder, it's gonna put these create table scripts out there, and then it's gonna put these test data creation scripts. What Postgres will do is it will order it, as long as you have it in this 0102 kind of format, it will execute them in order. So you do need to make sure that the files are in the right order of like execution to build out the schema. And then we'll notice that the compose YAML file grows just a little bit. So we need to build this container. We're going to give it like 256 megs here. I'm going to take this volume off first. And then we're going to expose this out to port 15432. So one of the challenges that we tend to have is we would mess up the data, you would do something in the app locally, and then you want to get back to that original data set to be able to continue to work on whatever you were working on. The repository, we've got a migrations folder, kind of a little more nested than this, but it has an order of migration scripts for our database. We've got like, I don't know, like 200 scripts or something at this point. It seems to be growing. And then we've got, what we ended up doing is we ended up, to build some test data sets, we ended up doing like desensitizing data from a production environment, and then doing a like a PG dump that would give you your whole entire data set out of the database, and then we kind of load it back in. So I'm trying to kind of recreate this over here by saying, like, here's some insert statements to get some data out there. So I will kick this off, and actually, as I do that, I might have, I think I need to update my, there we go, kick it off now. Okay, at this point, we got the Postgres database that's running out here, and we can see if this, okay. Well, I've definitely messed up something somewhere. I've missed a step. I'm going to blame it on the ports, is what I've done. Pointing back there, it's at 7 o'clock. I'm just going to quickly run through, like, in a quick minute of the rest of the thing. The volumes here is made so every time that you start these containers up, one of the challenges you're going to have is, do you want to reset the data every single time? You may not want to, right? Like, you're in the middle of something, you want fresh data, but maybe not that time. Or like, you're in the middle of something, you go home, you're going to start it back up. So if you have the volume, if you don't have the volume, every time you start the container, you're going to get a fresh data set because everything's going to run again. If you put this volumes in here, you're going to be able to save that data. So that data that's in the container in the Postgres, that's being copied over to your machine. And the next time you go in there, that data is still going to be in there. And so what you have to do is you have to delete that volume, and to kind of refresh that data. It gives you a little bit of flexibility on how you want to handle this. And then lastly, what I was going to share is, I will copy this over, is there's a lot of commands that we're running, which can be challenging to remember as these projects grow. So what we did was we're using make files. And make files are essentially going to allow you to automate some of your tasks, some build tasks and things like that, but you can run just about anything in them. And so we're kind of building out these shortcuts. So when you type in make, when you come into the repo, it's going to give you all of the make commands in a little bit of description of what they do. And then you can run any of these. So like, If you want to do a virtual environment, it's going to check if you have a virtual environment. If you don't, it'll recreate one. If you want to start your front end, you can just do make front end, and it will run those commands for you. And then we've got some other ones that we've started building is like make test, make lint. So everybody's using the same linter. If you want one for the formatter, you can have one. And then we've got things like install dependencies, which are going to install, like it will go find all the requirement files and install everything in that virtual environment. And then you can make one for like GitHub Actions, like the number of times that you go to GitHub and you press all the buttons. So we've got one that just for every environment that just says make, deploy, like the front end to this environment. And then you just have that command and it's going to execute all of that in the terminal. You can kind of go wild with this, but it kind of helps. If you've got many repos and you have this, you kind of know the first thing you go and type and make, you kind of have a good idea of like how to run this thing across all of the different repositories. All right, I will stop there. And I'll just go back to things can go wrong, even though I ran through it twice earlier today. So, anybody has any questions or anything? Yeah.
I was just going to ask, when you're building like a greenfield application or working with a team, and you're starting off in the beginning, at what point do you determine is the best opportunity to start containerizing the application?
Hopefully when something's working. So if you've got some of these services up and running, you're able to deploy your code and you've got something, right, like a base level product. And I feel like before you release that thing out to production, like you should start building these things early on, because it's definitely a challenge trying to go back and building it. And one of the challenges that we are facing is our repository isn't that big. We've got like 6, 7 different domain services. But as we started scaling, we started scaling really fast on those, and we're having issues where it just takes forever for like the compose up to run. So we're like going back and having to figure out like what, where are we not using caching, things like that. So if you start on these things early on and set a pattern before you get to production, I think that's probably like the best time. And then the make commands, or you can use, there's like task, I think there's a task list. Task file was the other one that I kept running into. You can, if you start making those and keep those consistent across your repositories, that would make life really easy for developers. Yeah.
You mentioned you had a couple different types of users that are using this, and you said people who are technical but not necessarily developers. Who is maintain? Is it the team that maintains this centralized solution, or are you having a centralized team manage for them? How does that work?
It's a team. So a few of us kind of built it originally, and then the team is kind of expanding on it. And as they're coming up with different needs, they're expanding it. But the original, to get to the point of like all of our services, it felt like it took a month of just like spending a few hours here and there. It was challenging to get it right the first time. And it was also my first time like really diving into containers myself. So there was probably a little bit of like learning curve on my end, but it was, it's once we had a pattern and everything built, it seemed like now it's being kept up to date.